Please calculate PAG using 0.05 molarity silver nitrite and nitrate. Titrate 25 milliliter of 0.1 molarity sodium iodide. And after the following additions of silver nitrate. Okay, so your analyte, your sample is 20 milliliter of 0.1 molarity. This is your analyte. Okay, and this is your titrant. Now I want you to calculate the PAG. This is what you want to calculate. And as we said, this is negative logarithm of silver ion. So we still have to calculate the concentration of silver, the titrant, at 3 different conditions. Okay, at VE, the equivalence point, 10 milliliter and 52 milliliter. Okay. So first of all, let's calculate VE. How do we calculate VE here? Anyone?
Do we add the original volume and the volume added?
No, I mean, VE is defined the volume of titrant that is needed to reach the equivalence point.
Would you use the dilution equation with the 25 ml and the 0.100 and the 0.05?
Okay, so you have 25 milliliter multiplied by 0.100 molarity. What do you get by doing this?
2.5.
I mean, like, what quantity are you getting from this? What is the moles? This is moles, right? The moles of what? Moles of the analyte. This is the moles of iodide, right? And then and the iodide and the silver is 1-to-1 ratio. So 1 mole of iodide is 1 mole of silver. So by doing this, you can convert the moles of iodide to silver. And then this is the moles, right? So how do you calculate the volume of silver nitrate?
Wouldn't it just be the mole-to-mole ratio of silver and silver nitrite, which is 1? And then,
yeah, so what after this?
So it would be 1 mole of silver nitrite over 1 mole of silver, since it's a 1-to-1 ratio, right?
Yeah, it's the same thing. Yeah.
So
what
and
after
then
that?
you get moles over liters, which is the 0.0500 molarity of silver nitrate.
So do I divide the number or multiply by the number?
You can divide, so it would be 0.0500 moles over 1 liter.
Okay, so this applies the M1V1 M2V2 equation. Okay, V1 will be M2V2 divided by M1. Okay, so after doing this, what is the volume we got here? Thank you, Hope, in testing, in putting the answer in the chat box and other people. So what do we get here for VE?
50 ml.
50 ml. And how many sig figs are we supposed to keep?
3.
3.
So 50.0.
Okay. All right. So since we already get VE, now what is the concentration of silver at VE? How do we calculate that? So you're actually looking at this equilibrium, right? At the equivalence point, all the iodide and silver will be reacting, form the precipitate. So you have everything in the precipitate, but the precipitate will establish a new equilibrium with the solution by forming silver ion and iodide ion, right? Now, if I give you the KSP, which is 8.3 times 10 to the negative 17, how do you calculate the concentration of silver?
You do KSP divided by the concentration of iodide.
Well, how do you calculate the concentration of iodide?
Professor, if you're at VE, don't you just square root the KSP?
Yes, that's what I'm asking for, right? So if we go back to previous slide, we said that at the equivalence point, the concentration of both reactant are governed by the solubility of product, which means that silver, if you write the equilibrium constant for this reaction, which is the solubility product, it will be KSP. And the silver ion concentration equals the iodide concentration, because both of them come from the precipitate. Again, at the equivalence point, everything goes to the precipitate. And then the precipitate will establish an equilibrium by dissolving in the solution a small amount. So you get equal amount of silver and equal amount of iodide. And then you just take the square root of KSP. Okay. And what do we get here? And how many sig figs are we supposed to keep here? Two, right? Thank you everyone for putting your answer in the chat box. So it's 9.1 sub 1, right? If you want to keep one more digits, times 10 to the 9. Okay. Just a quick note. When you're trying to use calculator to do this this calculation, you can convert it to 83 multiplied by 10 to the negative 18, right? And then this part, when you take the square root, it will be 10 to the negative 9, and you just need to take the square root of 83, right? So that's easier than just putting the whole number into the calculator, from my point of view. Okay, so since we get this concentration, now what about PAG?
Just do negative log of that number.
And what do we get here? And how many sig figs are we supposed to keep?
2. Wait.
This is a logarithm problem, right?
Yeah, 2.
2. Two after the decimal place. That's right. So it's 8.04. Two decimal places in mantissa part corresponding to the significance of the original number. Okay. All right, this
Professor,
is
what was the point of finding the VE?
what's the point of finding the VE?
Yeah,
because you
in
will
this
need a
problem.
VE for the rest too, right? How do you know whether the 10 milliliter is before equivalence point or after equivalence point?
Oh, okay.
Yeah,
But you
for
don't need
this
it for
one,
this specific
yeah,
part.
for this specific
Okay.
part, you don't need VE.
Okay.